All right, so we are going to look at word problems. This one is the distance equals rate times time with the two trains. So a train leaves New York at 4 p.m. A second train leaves the same city in the same direction at 6 p.m. The second train travels 24 miles per hour faster than the first. If the second train overtakes the first at 10 p.m., what is the speed of each of the two trains? With every word problem, the first thing you want to do is write down any formulas you know you're going to use, and then try to assign the numbers or information they gave you in the word problem to parts of those formulas. So our formula is, as we saw on that last screen, distance equals rate times time. In these problems, you have two different things, in our case, two trains. So you have two distances, two rates, and two times. To keep them separate, I'm going to label one with little ones at the bottom. These are called subscripts. There's nothing to do with math, it's a label. So that's the distance of train one equals the rate of train one times the time of train one. This will then be the distance of train two equals the rate of train two times the time of train two. So I'm going to go through and figure out as much as I can of each of those letters based on the word problem. All right, so one train leaves New York at 4 p.m. That's a time, but that's not a length of time yet. That's just a time on the clock. The second train leaves New York as well, and it leaves at 6 o'clock. The second train travels 24 miles an hour faster than the first. So the first piece of information that we can straight write down is right here. The 24 miles per hour faster than the first. That is rate, and that is the second train. So under the second train's rate, I'm going to put something plus 24. Well, the faster than the first, that means that is the rate of the first train. So I'm going to put R1 plus 24. Well, not only did they then just give me the rate of train 2, they told me that the rate of train 1 in my formula is just going to be itself. So if the second train overtakes the first at 10 p.m., what is the speed of each? So we do have some information with these times. The first train left at 4 and got overtaken at 10. So how long was it running? That is the length of time it was running. So 10 minus 4 is 6. The first train was running for 6 hours. The second train left at 6 o'clock, and it did the overtaking at 10 o'clock. So 10 o'clock minus 6 o'clock gives us 4. That doesn't always happen the way those numbers are just flipped from each other like that, but in this case, the time that train 2 is running is 4. So now here's the trick to these problems. You will have a couple of different ways they happen. In this case, we were in New York City. I don't know how to draw like New York City, but okay, there's a tower with a thing on it. And I'm really not going to try to draw the Statue of Liberty. Here's New York City. And the train that left, whoa, okay, train left. The other train left the same place, the same train station. So it just left at a different time. So from here to wherever this one gets overtaken by this one, notice that their distance is the same. They started here at the same train station and one overtook the other. That length of distance is the same. So for this problem, the key is that the distance of train 1 is equal to the distance of train 2. Well, we have distance equals rate times time. So the distance of our first train is the rate of our first train times the time of our first train. The distance of our second train is the rate of our second train, which is this weird one, R1 plus 24, times the time of our second train. We can simplify this stuff, and I'm going to take this information and put it on the next page. So we have distance of train 1 is R1 times 6. Distance of train 2 is R1 plus 24 times 4. And then this formula here. Okay, so those trains were going the same distance. That's why they're equal. We simply replace the D1 with this value for D1. And we replace D2 with this value for D2. So D1 is now R1 times 6, and D2 is R1 plus 24 times 4. I'm going to click back and make sure I didn't copy something over wrong. Okay, I think it looks good. Simplify. R1 times 6 is 6R from the first train. This requires distribution to be able to remove the parentheses. So we have 4 times R is 4R from the first train. 4 times 24 is 96. So we have an equation with one little variable. We're going to simplify this thing. We do that by whatever we do on one side of the equal sign, we do the same thing on the other. I'm going to get my R term over here. So I'm going to subtract 4R1 from both sides of the equal sign. Now I have 2 R1s equals 96. And now I divide to get R completely alone. So this tells us R1 is 96 divided by 2, 48. So I found something. Now I need to go double check what the question was, because we've done a lot of work. The question said, what is the speed of each of the 2 trains? Okay, so I found this one. I found R1, but it wants both of them. So now I need R2. That's okay. I know that R2 is whatever R1 is plus 24. So I'm going to turn my page back. R1 is 48. R2 is 48 plus 24 because R2 was R1 plus 24. So 48 and 24, that leaves R2 to be 72. My 2 answers for these 2 trains that are starting in the same place, going the same direction. One is going 48 miles per hour. The other one is going 72 miles per hour.